So in this we're looking at abstract data types, and one of the first abstract data types we're going to look at today is, hopefully you've guessed it now, is queues. So all abstract data types are collections of data, and each abstract data type has a set of basic operations. These operations are the ability to create a new instance of the data structure, to insert elements into the data structure, to delete elements out of the data structure, to find an element within the data structure, and to access all the elements in the data structure in a systematic manner. And this is true for all abstract data types. So what are the features of a queue? Well, in the real world, if we were in a shop and the people in the shop are denoted by these squares, and the letters inside the squares are the initials of each of their names. If one of these people want to join the queue, let's say F decides that they're going to join the queue, so they follow the tapes and they get to the front of the queue. And then A decides that they're going to join the queue, and they go behind F, and we'll put in a few more. There we go. And so if we've got items in a queue, we need to know where the front of the queue is, and we need to know where the back of the queue currently is. And if we know where the front of the queue is and the end of the queue is, then when we add more items to our queue, it's a simple case of just moving that pointer to the end of the queue. We add another element, and the pointer to the end of the queue moves back until it gets all the items. Now, obviously the point of a queue is that eventually the person at the front of the queue will be served. Now, in real life, what happens is that all of the elements shuffle down towards the front of the queue. But in a computer system, that's quite inefficient. There'd be lots of processing involved. So the easiest thing to do is to take the front of the queue pointer and move it to the second item. And then that item has been processed, or that person's been processed, and it can continue. Process another item, the front of the queue moves to a different pointer, and so on until the queue has been processed. Notice that the front of the queue can be the same as the end of the queue, but when there are no items, the front of the queue has nowhere to go next. So your algorithm has to take that into consideration, and a bit like a binary search, find an exit strategy. So for example, if the front of the queue is behind the end of the queue, does that mean that there's no items in the queue? If it's equal, so we have to come up with some sort of strategy for that. Hopefully that makes sense. So an item joins the queue, the front of the queue pointer is initialized, and at the beginning there's only one item, so it's also the end of the queue. And then when new items are added, the end of the queue pointer moves backwards. And when items in the queue are processed, the front of the queue pointer moves backwards. So when we're thinking about implementing a queue as a program, we have to think about how we're going to store each of the items in a queue. We would probably use a one-dimensional array. So in this example, I'm going to use a very simple one-dimensional array, and I'm going to use the single character data elements as shown in the last slide. We also need a pointer to the start of the queue and the end of the queue. And when I'm initializing the start position and the end position, I normally set the start position to be 0, which is the first item in the array. And end pos, instead of making it the same as start pos, because that suggests there's one item in the queue, I just make it equal to the start position minus 1, which is -1, which means it's out with the bounds of the array. So there are two ways of interacting with a queue. if you are an element. You can join the queue, okay, and that's also known as enqueue. And you can leave the queue, and that's also known as dequeue. So I'm just going to write out the functions to enqueue and dequeue. So in this procedure, we're enqueuing, okay, so we're adding to this queue array, we're adding this item to the end of the queue. And so the very first thing we do is we increment end position by 1. Remember, it's set up as -1. So to add it to the first element of the array, okay, if we're thinking that queues run from left to right, then we set end position to be 0, and then we add item, or we assign item to the element position 0 in the array, the queue. And obviously we're going to use this as a by ref, so we're changing the array inside this procedure. And when we end the procedure, go back to the main program. If we've asked to enqueue an item, the queue structure has now changed so that the item is at the beginning of the queue, or if there are more items, end position is incremented again and it will be added behind any existing items. So that's enqueue. Let's create dequeue. Now dequeue is a function that will return the item at the front of the queue. So in the function, we dequeue, we're taking in the queue, but we're returning a character. This will be the item that's in the queue. Now, I'm declaring an output, a local variable called output, which is a character, because I'm going to assign the value that's at the start of the queue to the output variable. I'm then going to increment start position, so start position becomes 1 or 2, and then I'm going to return the output character that I grabbed earlier on. Now, what these, I'm going to show this in an example on the next page, but what these two subroutines don't do is that they don't have any error checking in them, so it can't tell if you've run out of space in the array, it can't tell if you have dequeued all the items in the array, it can't tell if you decide to use a circular queue, which is a possibility, whether end position has reached the end of the available values, and the same with dequeue, the start position has reached the end of the available values and has to circle back to 0. But you know, for the basics, this is what you do with enqueue. You add an item to the end position element of the array, and to dequeue you return the start position element of the array, and then you increment the start position. So let's look at an example of implementing this over Leaf. So this example is going to have a few steps. Firstly, we're going to create the array. Create a queue, which is held in an array. Then we're going to enqueue a few items to it. So we're going to enqueue R firstly. So when we enqueue R, we take the element, we add it to the queue, and the end position changes so that it's pointing at the same position as the start position. If we then enqueue A, we call the procedure enqueue, which moves the end position by 1 and then adds the item A into the queue. And then if we decide to dequeue, when we dequeue, the item at the front of the queue is placed into an output variable. The start position is moved by 1, so it's now pointing at the same position as the end, and the character R is returned to the calling function, so X becomes R. And then if we were going to finish our program off, we would maybe display X or process X in some way. And that last step, outputting X, would display R to the user on the screen.